picking up right where we left off, we're going to be finding the domain of a few functions now. The first function that you see on the worksheet, 18x cubed minus 5x squared plus 37. So as we talked about in the last video, we're looking for three things. We're considering three things. First, all real numbers. Then we ask ourselves, do we see any denominators? No, we don't. Do we have any radicals? No, we don't. So the answer to number one, without any real work to do, is just all real numbers. So we'll start with number two, where we have g of x equals the square root of 5x minus 2. Now, this time we do have to ask ourselves those questions, all right? So we start with all real numbers, and then we say, do we have radicals? No, we do not have any do we have denominators? No, we do not have any denominators. But we do have a radical. So we take whatever is underneath the radical sign, and we set that greater than or equal to 0. So 5x minus 2 is greater than or equal to 0. That means that 5x is greater than or equal to 2, and x is greater than or equal to 2/5. We are going to put that into interval notation, and if you are not familiar with interval notation, we will be talking about it at some length later on in this video. But that means that we use a bracket to start because we are including the 2/5, and then we go on to infinity. So in interval notation, this is equivalent to this. And again, if you're following along on your notes, on page 4 of your notes, we will talk about interval notation in great detail. But for right now, there's our answer. So our next problem, we have h of x, and notice we're using all kinds of different letters for our functions, not just f's. We've got 3x squared over x plus 7. Starting with all real numbers, the numerator is not relevant, it has no radicals. All that we have is this x plus 7 in the denominator. So we have x plus 7 cannot equal 0. We will subtract 7 from both sides, and x cannot equal negative 7. In our interval notation form, that means that we will go from negative infinity up to negative 7. And not include the negative 7. That is why you use a parenthesis when you do not include something, unioned with negative 7 up to infinity. So these two statements are equivalent. If you only understand this one, for right this minute, that's okay. This is the way that answers are supposed to be given in what's called interval notation. We will be talking about interval notation in the notes later this video clip, or either this one or the next one, but in this series. Finally, we have k of x, or next we have k of x. We actually have 2, so it's not a finally. Is the cube root of 2x plus 1. We have no denominators here, and the index of this radical is odd instead of even. So this is all real numbers. So this one just goes from negative infinity to positive infinity. We have no problems. Our last one on this set, in example 1, says that m of x equals 5x divided by the square root of 2x plus 1. Here we have a radical in the denominator. So the 2x plus 1 must be greater than or equal to 0, but because it is in the denominator, it cannot equal 0. So we take that 2x plus 1 and we just set it greater than 0, not greater than or equal to. We remove the or equal to option because we are in the denominator. Subtract 1 from both sides, 2x greater than negative 1, x greater than negative 1/2. So that means that x is going to start at negative 1/2 and is going to go up to infinity, and there is our answer. The range of the function, which is the set of dependent values that correspond to x, is not always all real numbers either. But with range, things get a little bit more complicated. And for right now, we're not going to look at how to calculate the range from formulas. We will be talking about range when we start looking at graphs. So that is the end of Unit 1.3. We are all going to talk about 1.4 today as well, but I'm going to stop the video here because your actual live class starts in just a couple of minutes real time with me. So you'll hear me in the next video. See you soon.